And we're back. Okay. All right, so here's balloon tester from C4X10. Last time you should have had the constructor and the accessor get volume working, yes? Yes. Okay, so let's get this much working. You don't have to type in the blue stuff yet. The blue stuff is for later. But this was commented yesterday, and this was commented yesterday. I uncommented it. Okay? I uncommented it. Okay, so eventually we'll uncomment all this blue stuff down here, but how do you write this mutator is the point. Just do it. Okay. All right, so everyone has that? All you have in main is 1, 2, 3, 4 lines. That's all you need right now. Don't worry about all the comments if you don't have time, right? All right, just get this line running. Get this line running. We did that yesterday. Get this line running. That's today. And this line running, right? Okay, let's do it. So how do you do this? You do this. Okay. All right, so notice also yesterday we started doing Javadoc. Javadoc uses 2 stars. Okay. So what's missing? Add air is a what? Add air is what kind of a method? Mutator. I'm moving this up a little bit. All right, so you tell me, what should I write for add air? Public or not? Public. Void or not? Void or not? Not. It's void. It's a mutator. It doesn't return anything. It just changes the naughty bit. It adds air to the volume, right? So add air. What goes here? Not yet. Well, it could be 100. It could be 200. I don't know. Is it a double? Okay, double what? Why is it what? Because it doesn't return anything. It's a mutator.
Wait, we're supposed to just put mutator as the Java.
Yeah, we're going to talk about that in a sec. All right, so when you're inputting that 100 cc's or whatever it is, doesn't have to be 100. It could be whatever you want. So you're going to call it something. What? Well, that's a naughty bit. Amount? Okay. AMT. How about that? So what do you do in this mutator? Nothing? Good. Go home. No. Well, don't forget that you have a naughty bit that the mutator is going to modify, right? Air equals air what? Plus the amount, right? Okay. Whatever it is from main. Okay, and that's it. It's done. Save it. And test it. All right. So all we did was this, right? Well, while we're at it, why don't we do the Javadoc too? Here we go. I'm going to move this up. Don't forget there's a closed brace down here. I just had to move it out of the way because otherwise you don't see the stuff up here. All right, so let's do the Javadoc. What do I type here? How do I do the Javadoc? Double star, right? Notice that comments the rest of the program. Is that what you want? No, so close it. Okay, I closed it. Okay, that works too. All right, so what type of function is this? Mutator. Mutator, right, yeah. All right, and what does it do? Modifies air or volume. Modifies volume, how about that? Something like that, okay? Is there a return line? So you don't do an at return. Is there a parameter? Then you do an at param. The parameter amount is how much you blow. You're blowing up balloons. Relax. Okay, so we good? Okay, so save it. And let's go to a terminal. Ready? All right, here's my terminal. I'm going to shush in. Not there. What the heck? Where's my regular shush? There it is. Okay, shh. Did you shush in? Did it work? What's the final output? Just 100, right? Okay. All right, there you go. All right, so I got a CD to my stuff. Do I have a CD in here?
Can you go to the tester real fast?
Test it real fast?
Yeah, just make sure I do this.
Where did my shell go? I just had a shell, it went away. There. Why is it there? That's odd. Okay. Move this out of the way. Okay, anyway, so there's a tester. And where did my shell go? That gives me a new shell. Where did my shell go? Oh, well, whatever. All right, so there's a tester, right? So let's go to the shell. Here we go. Okay, so it's, I need a CD. Where's my CD from yesterday? Is that it? Well, 10. Okay. All right, so let's do it. Java, C, balloon, tester.java. Good. And then running it. Da, 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 ding. And so, did you expect 100? Yes. You did. Who's stuck? I got one error. You got one error? Okay, good luck with that. Okay. So does everyone have the tester? Not the blue stuff? That's okay? Everyone has this? Right, I have a closed brace down here. It's off the screen because otherwise, without this white space, I can't move this up, right? All right, so is everyone stuck? We didn't get 100 in the output. Okay. All right, YouTube walking around. All right, see if we can do get radius. Think about that. How are you going to do get radius if you got add air working? Capital S. It's a class. And there too. Oh, there. All right, save that. Try that. Can't find get volume, really? Do you have a get volume? There it is, right? So what the heck? Yeah, alrighty. Right, hang on. Whoop, Twitter, shut up. Wow. Let's make this a little bigger. Well, it starts here, right? Okay, it doesn't like your line 10 in balloon. Oh, there's no. Right, line 10 in balloon. Well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, public balloon, open parentheses, close parentheses. All right, it's a constructor with no input, right? Okay, save it. All right, so where's your shell? There it is. Okay, try that. Where, now it's just a semicolon. Okay, so where was it? All right, saving that and try that. All right, now run it. Anybody else stuck? Yeah, okay, hang on. Ta-da! Well, did you make it 150 in the tester? Okay. Oh, you're looking up stuff. Oh, you're integrating everything. Yeah, what? What? Help you print something out? Okay, so go ahead. All right, I have to help you print? Are you kidding me? Okay. Oh, what's that, word feud? Okay, what happened? Well, where are you? You're not where you're supposed to be. CD, your name. You know, your login name. Okay, enter. Okay, now what? You have a C4 EX10, CD that. You must have CD'd too many times. Did you Java C or anything? You did a Java C, didn't you? Okay. Oh, there's a problem in line 31 of balloon. Line 31 of balloon. Really? I don't see it. Oh, actually it's after. You're missing that. Yeah, all right, try that. Ta-da! Now run it. Okay, who else isn't running? Okay, so how are you going to get the radius? Notice, we're not inputting the radius and asking for the volume. We're inputting the volume and asking for the radius. Oh, that's so complicated. Isn't that complicated? No. No? Really? What's the volume formula for a sphere? The air is the volume of the sphere, right?
4/3 times pi times radius cubed.
4/3 pi r cubed. Right. Okay. So let's talk about that.
I didn't look up, but then I checked it.
You checked it? Good. That's a good thing.
I checked it last time when I was doing it, but I knew it.
Okay. Okay. That's good. All right. So let's talk about that. Alrighty. So I'll do this, and I'll do this, and I'll do this, and I'll do that, and I'll do that. Zing. Okay. Well, I might as well just go up here. All right, so if you have a sphere, I can do this with my tablet, but I'm getting tired of tablets. Sorry. So say you have a sphere. Pretend it's a sphere. It's a cross-section. Okay? All right. Now, it has a certain radius, right? Damn it. Right? Say that's the radius of the sphere. All right. You know the volume, don't you? The volume of a sphere is 4/3 pi r. It's volume. It can't be squared. R cubed. It's cubic centimeters. It's got to be R cubed. The only dimension is R, so you're going to be cubing it. We could derive this in calculus using integrals and stuff. We're not going to do that. But the question is this. Usually what they do is they tell you what R is. You plug it in, you get the V. But that's not what we got. We got V. That's our naughty bit, air. If you got V, how do you get R? Can you solve for R? How do you get rid of the 4/3? Multiply by the reciprocal, right? So 3/4 of V is pi R. Ugh. Ugh. It's connecting stuff. Pi. More yuck. Wait, hang on. Pi r cubed. All right, now what? So what are you going to do? Divide by pi, okay. So let's divide by pi, and we get 3v over 4 pi is r cubed. Okay, you're almost there. I don't want r cubed. Cube root everything, right? Okay, so r, that's right. That's what we got to figure out in Java. R is the cube root of 3v over 4 pi. Well, how do you get pi in Java? How do we do pi? Math.PI. Right. How do we do the cube root? Yeah, but this is a calculator.
Math.pow.
Math.pow, right.
3.0.
Right. Exactly. See? Amazing. Math.pow, yeah. Okay. Math. I can't write. Math.PI. Notice the convention. Math is a static class. Proper case. Pi is a constant. Uppercase. Right? Don't mess it up. And Math.pow. It's a method. So to open close parentheses, right? And it's a method name, so camel case. Now what does pow do? If I say I do a system out the print line of pow 2, 3, guess what you get? Is 8. That's how you use pow. Okay, let's do it. So let's write the method getRadius. It does all of that. Alrighty, so good. All right, getRadius. So let's get rid of Zernal. There it goes. Let's get back into the editor. All right, so I'm going to go into the tester and get rid of this comment. So now you have 6 gray lines. You don't have to have the blue lines. You have the 6 gray lines in your main. All right, so constructing the balloon, printing its volume and its radius, adding air to the balloon, getting the new volume and the new radius, right? So do you have these 3 lines?
Wait, you have to ask for the
and
radius of the surface
these 3 lines, and we're going to use getRadius in the surface area method, yeah.
Wait, we use...
You can use a method inside a method.
Oh, really?
Mhm.
Oh, and I redid the whole formula.
That's reinventing the wheel.
Wait.
That's counter to object-oriented programming where you're not reinventing the wheel. You're reusing code.
Wait, so do we have to ask for the surface area, the volume, and the radius? Well, I know we have to ask for the volume when we have no volume.
Uh-huh.
But we have to ask for the radius and the surface area too.
Well, yeah, look, they did. Every time the volume changes, I'm printing the volume, the radius, and the surface area. Every time it changes. Okay. All right, so do you have this tester? 6 lines? You don't worry about the blue. Right? Are we good? All right, let's go to the class. Save this. All right, in the class, I'm going to add a new method. What is it? What is it called? What? getRadius. What is that? Public or not? Public. Void or not? Nah, no, not neither. It's double, right? Because it's returning the radius based on the volume that's based on Math.pow that returns W. Returns double. And Math.py, which is a double, right? So it has to return a double. It's called get radius. Get radius. Okay? And so what's the one line you're going to write? It's one line. Return something, right? Return what? Oh, I exited out. Okay, what was it? It was the cube root of 3v over 4 pi, right? Yeah. All right, so let's write that. Ready? How do you do the cube root of something? You gotta move this up.
Math.pow x.
Okay, so Math.pow of stuff, comma stuff. Okay. What are we taking the cube root of?
3/4 of it.
It's 3 times
Air.
the volume, which is air, okay, divided by,
4 divided by math.pi.
right, divided by 4 divided by math.pi. Is that the same thing as dividing by 4 times pi in parentheses?
Yeah.
Okay, you could write it that way if you want. You want to write it that way? Fine. That's right. So I usually write it that way, but you can write it this way. Right, so that's a denominator. The numerator doesn't need parentheses because you're going to multiply first anyhow. You want parentheses around the numerator to play it safe? Go for it. Okay? Now, how do you get the cube root though? What power is that? What exponent is that?
1 over 3.0.
Right, don't do this. Right? What's a square, for example, what's the square root of 4? 2, but what is that? That's 4 to the what exponent? 1/2, right? So what's the cube root of 8? 2, but how do you write that? 8 to the what exponent? 1/3. But don't write 1/3, that's wrong. Why? Why is that wrong?
Because it will give you 0.
Because that's an int and that's an int, so you get an int. That's not divide, that's div. 1 div 3 is, 1 div 3 is, you came up with this problem the other day. It's what? 0. Right? In other words, how many times does 3 fit into 1 integer y? 0 times. Aha, that's not what I want. I don't want to race to the 0. What's something to the 0, by the way? 1. They would always give me 1 no matter what your radius is. No matter what your volume is. Right? That's not what you want. So how do you fix it? How do you make it actually calculate 0.3333333? You need a decimal somewhere. Either in the numerator, 1.0, or in the denominator, 3.0, or both. All right, how about here? That's it, done. Okay, you're done. Don't forget, I have a closed brace way down here. You don't see it because I had to move stuff around so you can see this, okay? All right, so save that, and let's test that much. Are you ready? Okay, here we go. This is all we wrote. You got it? That's all she wrote. The cube root of 3 times the volume divided by 4 times pi. That's all we got to do. All right, so let's do it. Do I have a... I don't have a terminal open. What happened to my terminal? I could have sworn I had a terminal open somewhere. I do. So why doesn't it show? Why isn't it showing up on the side here? That's weird. All right, anyway, here we go. So, Java see it, and Java it. And did you get a... Oh, wait, I didn't save the tester that I changed. Tester, save. Yeah, I did. Wait a minute. Why isn't it? It's printing the radius, the volume, and the radius, right? Oh, I meant to say radius here. Whoa, radius. Yeah, that's weird. And how about surface area? Okay, whoops, sorry. Yeah, it said volume equals volume equals. No, volume equals stuff, radius equals stuff. I messed up the string. Whoops, silly teacher. Alrighty. So let's go over here. All right, so when your volume is zero, your radius is 0. Does that make sense? And when your volume is 100, your radius is 2.879 something. Well, I don't know. Let's check that with a Ziggy. You know Ziggy? Who's Ziggy?
That's my boy.
Who's Ziggy? You're TID3. Hello, Ziggy. Where are you? Why isn't he coming out? There's Ziggy. All right, Ziggy. So let's try that on Ziggy. Now remember what we're doing. The cube root. How do you do this on Ziggy? The cube root of 3 times volume over 4 times pi, right? So cube root. How do you do cube root on here? Something to the 1/3, right? Okay. So here's the something. It's quantity. 3 times 100 was the area, right? Sorry, the volume, right? Divided by, okay, quantity, 4 times the pi. Well, here's pi right here, second caret. You know your TID3s, don't you? All of that is being raised to the 1/3. Now here, Ziggy does 1/3 the way you would think it does it. That is 0.3333. And so do we get, what are we supposed to get, 2.879-ish? 2.879-ish. Aren't we good at this? Yeah, it works. Beautiful. Very nice. All right, so get rid of Ziggy. And so did you get 2.879-ish? Anyone not get that? Oh, my goodness. Okay, walking around YouTube. All right, if you got that working, go for, what's the last one? Get what? Get surface area, right. All right, so what's the error? So many errors, so little time. What the heck did you do? All right, so it doesn't like, I don't know if you can. Go ahead. It doesn't like, what? It just doesn't like line 21 at all. I mean, 21, forget it. Oi. Line 21, line 22. Line 21, line 22 in here or in the other one? I guess 21 in here, right? No. Wait, you don't have a line 21. Oh, yeah, you do. It's over here. I'm sorry. Well, first of all, I messed up. That should be radius. Right, that doesn't make any sense. Printing volume twice is crazy. Same thing there. But it doesn't like this line? But this line is the same as this line, right? Yeah. Oh, yeah. You're doing this. Right? Okay, now you're... So, all right. So when you create the balloon, it's going to have a 0 volume and 0 radius. When you blow in 100 cubic centimeters of air, this should be 100, and this should be that 2.8 whatever, right? All right, let's save that. All right, let's get out of here. Where's your terminal? Where'd it go? Your terminal went away. Are you kidding? Oh, there it is. All right, so let's... No. Let's... What? I thought I had a clear in here. Hang on, clear. Okay, so now let's do the Java C. What is this? It doesn't like add air, by the way. Did you test add air? You should be testing add air before you do get radius. You're supposed to have had, printed 100 before you started with the radius stuff. Illegal start of type? What? Oh my goodness. Let's see, where's your add air? Here it is. So public void add air, double amount, and the amount gets added to air. Right, that's fine. Perfect. All right, so it doesn't like add air. Why? Is it like... Hello? I lost a pointer. Why don't I have a pointer? It won't let me check over here.
The only problem with the site is how much time it takes up.
This is fine. I don't see the problem. Well, I usually indent more than that, though. Right? I would tab all this stuff in. Oh, I see. You're missing one thing here.
It's also very funny, but
tab, close, brace. Right? You had an open one here and no close. Oh, you put it there. Right. Get rid of that. We added more stuff after that. That's why. Okay. That's why this went crazy. Okay. Is it saving or not? It's not saving. What's going on with your screen here? This is acting stupid. File, save. How about that? And this one. Ugh, again with this. Balloon tester. File, save that then, okay? There you go. It's saved. Okay, fine. So now we go back into here, and we do this, and we do that, and it's better. And now we get rid of that. So it was the brace. And yeah, good, perfect. All right, who else is stuck? I collect those. I have a big collection. Put it away. What? Whoa, what are you doing? Oh, your surface area. All right, but you got radiuses working, right?
Yeah.
Okay, we didn't talk about surface area yet. Well,
I thought we were doing that right now.
yeah. I'm still fixing radius for people.
Oh, I found it.
Yeah, you're reinventing the wheel because aren't you plugging in the radius? Aren't you? You rewrote all of this in here somewhere, right?
Yeah.
Don't have to do that.
So
Just
type
call
radius.
get radius in here. All right. So were you stuck with radius or what?
No, I got it.
You got it? Okay. Who else is stuck? Anything on radius up to radius? All right. Now surface area. How to get surface area? Do you remember surface area? 4 pi r squared. All right. How to get r? How to get r? The radius. We already have it. Don't we have a get radius? So your code is going to use get radius. What if you initialize what? Where? Oh, you have naughty bits for all this stuff? Yeah, well, you could do that, but then it's not really an accessor, it's also a mutator. We try to avoid that. It's easier to debug your program when you have problems. If you have accessors and mutators separate, not both. This is called the hybrid method. I would avoid that like the plague. All right, so you don't need those naughty bits. Just return that value. Okay, so let's do 4 pi r squared, but r is get radius. Yeah.
It's one there, but I can't.
4 pi. Get radius is a method, so you need parentheses here. Okay, let's write that. Get surface area, right? Okay, so go back to your tester and uncomment everything. So I'm going to get this working now, right? Save that. And now go to balloon, and let's write this other accessor. All right, what did you write? Public or not? Public. Void or not? Void, really? It mutates? Double get surface area. Is that how I wrote it in the main? I forget. All right, so you're going to return what? What do you write? Math.PI, okay, yeah. Times 4, okay. Times get radius, that's all. Don't reinvent the wheel. Reusable code is at the heart of object-oriented programming. What? It's get radius. Oh, squared, right. So what am I missing? Math.pow of that, comma 2. Or you could do get radius times get radius. You did that? Yeah, okay. But I'm trying to use the math classes as much as possible to show you how it works. All right, so save that. All right, so does it work? Well, let's see. Wait. All I wrote was one line. This is, well, I wrote it the other way. I wrote 4 times math.pi, but big deal, same thing, right? All right, so you got all that? 4 times pi times get radius squared. Whoops, that should be what I do there. That should be a comma. What am I doing? Okay. All right, shall we test it? All right, let's test it. All right, so here I'm going to Java C it again. And here I'm going to Java it again. And apparently the surface area, when the volume is 100 cc's, the radius is 2.879 centimeters roughly, and the surface area is 104.188-ish. Is that what you got? Well, we should check with Ziggy. Did I kill my Ziggy? Where's my Ziggy? I killed my Ziggy. Where's my Ziggy? Why is Ziggy taking all day today? There we go. T83. I give my calculators nicknames because I'm sick of, oh, take out your 82. Oh, you take out your 81. Oh, take out your 83. Oh, take out your 89. Oh, take out your... Ziggy, Hal, Klaatu, Obi-Wan. Okay.
Wait, who's Obi-Wan?
T81.
81.
The 81, Obi-Wan, it rhymes. What's wrong?
Why do you even have an 81?
Huh?
Why do you have an 81?
I started teaching when graphing calculators were young. So I've used them all. All right, anyway. So let's test this. Okay, second quit.
The Force.
All right.
Wait, do you have an Inspire on there? You should name it the Force.
No, the Inspire is Dr. Neville.
Yeah, but then,
You know who Dr. Neville is?
no,
No? I Am Legend?
I did not like that movie.
Omega Man? Last Man on Earth? There's 3 versions of that movie.
Wait, really? They're all
The-
the,
the-
same movie?
They're all related to the same novel.
Because my mom saw Last Man on Earth and said it was like really bad, and I said,
Yeah, that was really bad. The only thing good about it was Vincent Price, but... All right, anyway, so let's do it. Now, don't forget, it was the cube, it was, what was it? The heck was it? It was 3 times 100, right? Divided by 4 and pi to the 1/3 is the radius, right? Now I got to take that and square it and multiply by 4 pi, right? So let's take that answer. Let's do 4 pi times the answer squared. Is it 104 point whatever? It is. Amazing. All right, YouTube, we're done. Bye-bye.